And then we end up with our explicit rule. All right, next we're going to look at a couple sequences and see if we can come up with the pattern. Okay, so what I would like you guys to do is first, you can pause the video, look at these, study them a little bit, see if you can come up with the patterns. Okay, so we're trying to find the next term in the sequence. So go ahead and pause it, look at the patterns, try and find them, see what you can get, and then, okay, so then you can go ahead and unpause it. Hopefully you've found at least one of the patterns, even better if you've found both of them. So looking at those, various different things that you can look for with the patterns. First of all, two of the more basic patterns that you can look for is if you're adding something or multiplying by something. Okay, so you can kind of see if there's a pattern in what you're adding. You can kind of see if there's a pattern in what you're multiplying. So here I'm adding 7, then I'm adding 21, then I'm adding 37. So I don't see much of a pattern in what I'm adding. So then we can look at multiplying. So to get from 1 to 8, we have to multiply by 8. To get from 8 to 27, we actually have to multiply by 27/8. And then 27 to 64 would be 64/27 that we'd have to multiply by, and there's not really a pattern in that. So those are the two patterns I would look for first. The other patterns that you can look for, some other common patterns to look for, is look for something to do with exponents. As in, not like in the previous one where we were taking 2 to a power, because that's actually going to be where if you're multiplying by the same thing over and over again. But specifically look at when you've been taking, or these numbers are all being taken, are all a number to the same power. So think about your perfect squares: 1, 4, 9, 16, 25. See if either of the numbers that you're looking at are perfect squares, or sometimes even like one more or one less than a perfect square. Or think about your perfect cubes. Okay, looking here, your perfect cubes are 1, 8, 27 is 3 cubed, 64 is 4 cubed, so maybe you're seeing the pattern now if you hadn't already. This is all numbers being taken to the third power. So the fifth term is going to be 5 cubed, which is 125. Alright, then looking at the second one. And this one, again, if you're checking the adding the same number, subtracting this, or adding the same number, sometimes when we are talking adding a number, we're adding a negative, but you'll see in a later section that generally we still refer to it as adding a number. It's just that we're adding a negative to it. So we check that here. So to go from 20 to 17, that goes down by 3. 17 to 13 goes down by 4. 13 to 8 goes down by 5. So we're not going down by the same, but you may have recognized a pattern here. With that idea of adding something or multiplying by something, sometimes it is the same number over and over again, like you saw in this pattern. This time it was timesing by 2 every single time. Sometimes you might see a pattern where you're not doing this, you're not multiplying or adding the same thing every time, but there's a pattern in what you're adding or multiplying. In this case, what I'm subtracting, or it's a negative, it's going down by an extra 1 each time. So it started going down by 3, then it went down by 4, then it went down by 5. So the next thing's going to go down by 6, which is going to make that next number 2. All right. Last thing that we're going to look at is the idea of series along with this summation notation. So summation notation is this E-looking symbol. This is called a summation. And this is a notation that is used in series. It's a notation used to write a series. Now, a series is simply a sequence added together. So it's when you take all the terms in a sequence or number of terms of the sequence and add them together. So that's what this summation symbol means. It means the sum of. And with that, you'll notice you always have a number on the bottom. So in this case, k equals 3. That's where we are beginning. So what this is saying is we are starting with the third term in this sequence, which would be 2 times 3, which is 6. 6 plus 2 is 8. So 8 is the first number we're starting with, the first term. We're starting with the third term, which is 8, and we're going to add up each of the terms until we get to the sixth term. Okay, so that's what that top number represents. Now, I want to point out that the top number doesn't necessarily say you're adding 6 numbers. It means 6 is the last number that you plug in. Okay, so the bottom number tells you, and the bottom will always have a letter attached to it. You could put it on top and the bottom, but we only need one letter. We only need it in one place just to let us know which letter we're plugging in for. Because there are applications of these summation problems where you might have multiple letters in there, but only one of them is the one that you're plugging stuff in for. That gets more into calculus level stuff, but that's why we have that letter attached to the bottom, just to say this is the letter that you're plugging these numbers in. So first what this is telling us to do is plug in 3, and then take that number and add to it what you get when you plug in 4. So if you plug in 4, that's 8 plus 2 is 10. Then plug in 5. 10 plus 2 is 12. Then plug in 6. 12 plus 2 is 14. So we plugged in 3, 4, 5, and then plugged in 6. So first number we plugged in was 3. The last number we plugged in was 6. And we plugged in all the numbers in between. And we're going to take the numbers that we got when we plugged those in, and we're going to add them together. That is what this notation means. So what we have here is 8 plus 10 is 18, plus 12 is 30, and 30 plus 14 is 44. All right, so let's look at another one. Feel free to pause it, try this one on your own. The sum of, from when n equals 1 to 7, of n squared. So this means 1 squared, which is 1, plus 2 squared, which is 4, plus 3 squared, plus 4 squared, plus 5 squared, plus 6 squared. Forgot what that was for a second. Plus 7 squared, which is 49. And then we go ahead and add those together. So you could probably do this faster with a calculator than I'm going to do it in my head. That's 50. That's 40. That's 90. 9 and 16 is 25 and 25, so that's 50. 90 plus 50 is 140. Hopefully I did that right. I think so. Alright, last one. The sum from when x equals 1 to 20 of 5. So you'll notice that there actually isn't an x here. So if there is not an x, sorry about that. So the first term would then be 5, the second term would be 5, the third term would be 5. So we actually get here is 5 plus 5 plus 5 plus 5. Start at the first term all the way to the 20th term. So we end up with plus 5 20 times here. So you can go ahead and type into your calculator 5 plus 5 plus 5 plus 5 plus 5 plus 5 20 times. Or we can do it faster and say that that's 5 times 20. So 100. All right, that is all for 8.2.